Hi everyone, we're now going to talk about the domain, range, and vertical asymptotes for y equals tangent of theta. Now in fact, we've talked about the range before. Let's review that. What are the possible real numbers we get as slopes, as tangent values? Well, all real numbers. Because a tangent value or slope can be 0, positive, like 1, 2, a million, a billion, or any negative real number, -1, -10, -a million, -a billion. Any real number can be a slope, so any real number can be a tangent value. If you look at even just one cycle, remember the y-coordinates here are the tangent values, the y-coordinates here are the slopes on the unit circle. The y-coordinates here are the slopes on the unit circle. And again, what are the tangent values we pick up? We pick up all real numbers as y-coordinates, as tangent values. That's why these snakes are infinitely tall in both directions, up and down. Any real number can be a slope. The tangent is all real numbers. Now, I'm going to discuss the vertical asymptotes, or VAs, for the graph of y equals tangent of theta, and then we can figure out the domain. First, the vertical asymptotes. So here's the key thing. Where is tangent of theta undefined? Where is tangent undefined? So in particular, the slope of what kind of a line is undefined? The slope of what kind of line is undefined? The slope of a vertical line is undefined. So imagine this vertical line going through the origin. We're going to have a problem at angles corresponding to the North Pole up here and the South Pole down there. Tangent, slope, is going to have a problem. Tangent will be undefined at the corresponding angles. Well, what angle do we typically associate with the North Pole of the unit circle? Typically, pi/2. Tangent of pi/2 is undefined. And what angle or angles do we typically associate with the South Pole? Well, negative pi/2 is one, 3 pi/2 is another. In fact, there are infinitely many angles where tangent is going to be undefined for both the North Pole and the South Pole. Pi/2 and its coterminal angles, and 3 pi/2 and its coterminal angles. So how do we get from problem angle to problem angle? Start with pi/2. Pi/2 plus how much will give us 3 pi/2? Pi/2 plus pi radians will give us 3 pi/2, because that's half a revolution around the unit circle. And then we do another half revolution to get another problem angle, 5 pi/2. So we keep adding pi radians, or we could subtract pi radians in this direction to get these problem angles. Going back to this larger graph for y equals tangent of theta, where were our problem angles? At theta equals pi/2, 3 pi/2, and then 5 pi/2, 7 pi/2, and so forth. Going backwards, negative pi/2, negative 3 pi/2, negative 5 pi/2, and so forth. We have infinitely many VAs. And where are the problem values? Tangent of theta is undefined if and only if theta is of the form pi/2 plus pi n, where n is some integer. Another way you can write that, where n is in the set z. In fact, we'll usually write it that way, where n is in the set of integers. We have a problem. Tangent is undefined when theta is of the form pi/2 plus 0 pi, plus 1 pi, plus 2 pi, and so forth. Also, minus 1 pi, minus 2 pi, and so forth. N could be 0, a positive integer, or a negative integer. We do not need plus or minus. Now, if you notice the angles the values for theta in radians for which we have a problem, where tangent of theta or slope is undefined, remember, it was 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so forth. Also, negative 1 pi over 2, negative 3 pi over 2, negative 5 pi over 2, negative 7 pi over 2, and so forth. So another way to write this is to factor out pi over 2. Don't worry about this, but you could factor out pi over 2, and you get 2n plus 1 all times pi over 2. In chapter 9, we're going to see that 2n plus 1 represents odd integers if n sweeps out over the integers. So we have a problem when theta is an odd integer multiple of pi over 2. For example, 1 pi over 2, 3 pi over 2, and so forth. Also, negative 1 pi over 2, negative 3 pi over 2, and so forth. In any case, these are the equations for the VAs, the vertical asymptotes of y equals tangent of theta. Every vertical line of the form theta equals pi over 2 plus pi n. Where are the problem values? At theta equals 1 pi over 2, 3 pi over 2, and so forth. Theta equals negative 1 pi over 2, negative 3 pi over 2, and so forth. So these will give us all the VAs for the graph of y equals tangent of theta. Another way of seeing that, not only are these the places where tangent or slope is undefined, at the North Pole and the South Pole, there's another way of looking at this in blue. Remember that tangent of theta, by the quotient identities, is sine of theta over cosine of theta. Where do we have a problem? We have a problem when cosine of theta is what value? We have a problem when cosine is 0 in value, when the bottom is 0. Well, think about the unit circle again. Think about the unit circle. I'll go up here. Think about the unit circle. Where is cosine 0? Where is cosine equal to 0? Cosine is like the x-coordinate on the unit circle. Well, where's the x-coordinate equal to 0? Again, up at the North Pole and at the South Pole. So there are two ways of seeing why we're going to have problem angles at the North Pole and at the South Pole, because the slope is undefined over here for this vertical line, and also because the cosine value, the x-coordinate, is 0 at the North Pole and the South Pole. So those are two ways of seeing that we're going to have problem points at the North Pole and the South Pole corresponding to these angles. Now, if these are the angles for which tangent is undefined, what's the domain? Be careful. The domain of the tangent function is the set of all real values of theta. Nowadays, I like to write this. The set of all values of theta in the reals. I like to put in the reals. The set of all theta values in the reals such that theta is, take a look at this. I'll put this in red, such that theta is not of the form. Is not the form. Pi over 2 plus pi n. Remember, these were the angles that gave us VAs. The domain is the set of all angles, theta, such that theta is not where we have a VA, not of the form, pi over 2 plus pi n. Don't forget to slash the equal sign. In other words, theta is not like 1 pi over 2, 3 pi over 2, and so forth. Again, this is the domain for the basic tangent function. It's all real values of theta where we do not have a VA. Do not. Don't forget to slash the equal sign. Next, we're going to discuss cotangent of theta. And don't forget, the range was all reals. We mentioned that before. The range is also all reals for cotangent, as we'll see.